Hi, I'm Matt, and in this video we are going to be showing you how to set up a Naze32 board for use with a flying wing that has elevons. Now, this video is going to be in two parts. The first part is the wiring, as you can see on the desk in front of you, and the second part is going to be the settings which we've got in CleanFlight. Now, the obvious question is, can this be done? Well, the good news is, yes, it can. And the second question is, why would you want to use a Naze32 board in a flying wing? Well, this kind of boils down to a couple of reasons. Firstly, the challenge. There are very, very few videos out on the interwebs which show you actually doing this. In fact, there's very few, and the ones which are out there, no one has actually covered the actual setup of setting up a Naze32 board with GPS and other sensors as well, so that you can use this within your flying wing. Now, by adding a Naze32 board to your flying wing, it gives you several really cool features. Now, the big one is stabilization. And this one's really, really cool because it gives your plane stabilization. So if you get blown with wind to side, it will keep it on straight and level. The second one, oh, by the way, that's really important if you're using your flying wing as an FPV platform. And also note the FPV piece that we've got a note on OSDs in a moment, and I'll get to that as well. There's several other cool features such as height lock or altitude lock. You can also lock the head in. You've also got features like GPS home in there. You can add a sonar sensor for low level flying. Now, a little note there, that's 3 meters or less. You can, with adapted firmware, I hasten to add, you can also set up waypoints, so you can go to one corner of the field and then turn to the other corner of the field and then go back to the other corner. You can do really cool things like that. You've also got Loiter Mode, so maybe you lose control, you whack GPS home to get the plane to come back to you, and then when it comes back home, that you can kick it into Loiter Mode and it will just circle around your head. Well, that's the plan anyway. You're going to find out if that works in later videos. Now, back to the point around the OSD. Now, an OSD means on-screen display. So if you're thinking about using your flying wing with FPV, now for literally a couple of quid, I mean like 5-7 quid, you can buy these little OSD boards, and these give you like a heads-up display or a flight display, which can give you lots of cool stuff, such as the heading, and of course the flight sim style screen display, and I'll pop that up on the screen so you can see what I mean. You can see the GPS coordinates, the height or the altitude, the current consumption, voltages, ground speed, and so on. Oh, and you can also record your flight data too. Now, I will be showing you how to set up GPS fix alerts on the Taranis handset in a later video. Again, it's something which I've come across, a challenge to try to do. Couldn't find any videos out there on the interwebs, and I'm going to make a separate video for that. Now, let's get into the bulk of this. Part one now is going to be looking at the wiring first. So, first point is I'm using a Naze32 revision 6 board, and I'm using the 10 DOF for this, so it's the full board which I'm using. We have a FreeSky D4R2 receiver, and again this one's completely knackered because I smashed it up in a crash a little while ago, so it's fine for the bench but not really good for flying around with. And this one's been set up in CPPM mode. You know it's in CPPM mode because we've got the jumpers across pins 3 and 4, and we've only got a single lead coming out, which is being, and we've got that being fed into the Naze32 board in the normal fashion, and we've the black and white wires here, black and red wires are just the power for the actual receiver, and the data is transferred down this white wire into pin 1, I believe. Also, it does look kind of complicated, but to be honest, it's really, really straightforward. And the bit which makes it complicated, or makes it look complicated, is this extra wiring block here. And to be honest, that's really, really straightforward, because this green wire, which then turns into a blue wire down here, is actually the telemetry, and we're feeding data back from the Naze32 board through this green wire into our receiver, which then transmits that back to our handset so that we can see really cool data back on our handset. Also moving on, we've got two servos connected, so those are for our elevons. So just on a fixed wing, you don't have a rudder and an elevator. Instead, you've only got two movable fins, and they do left and right, just like ailerons would, but they also do up and down, so just like an elevator. So that's why they're called elevons rather than ailerons and an elevator, if that makes sense. The motor would normally go onto servo pin number 1. I haven't got that connected here, but I know that that works as well. I've been and tested that. Moving around the board, the next thing which does kind of look kind of scary is that I do actually have an Oled board or Oled screen connected to this. It's not absolutely required, but I thought it was a nice little feature so that before part of the pre-flight checks, I can see the current status of the Naze32 board. I can see if we've got a GPS fix, and I can also see if the board is actually armed or not, because you may set the board as being armed on your Taranis handset, but maybe you didn't get a 3D fix and that hasn't actually armed your board. Okay, with the Oled screen, which is only a couple of quid off eBay, you'll be able to see the status of that, and ultimately it's only 2 wires, and the second you arm it, then the screen doesn't update anymore. So and it's an OLED, so the power consumption is absolutely tiny. The next one which we have connected here is just a straightforward buzzer. That's great as an audible alert for when we've been and armed the board or disarmed the board, and also this also doubles up as being a lost model finder as well. You can set this up with a mode, which I'll show you how to do in a few moments in clean flight. And then you can set a buzzer alarm off on one of the switches on your handset, so you can just get that to go beep in the background. So if you do lose it in a tree or something like that, you can do that and it will help you find it. Now, the last thing which we've got connected here is a U-Blox GPS receiver. Again, it looks scary, but it's actually really simple. Number one, it's really simple to set up, and number two, the wiring, you've got black and red, which is just power, and the other two are just the data lines, and it's straightforward as that. And I've got a little 3D printed box which helps protect the GPS as well, and again, especially if that's going to be mounted on top of the plane, and again, this, you would want this mounted as far away as possible for the rest of the electrical components, so that you get a good GPS fix all of the time. Now, that's the setup. The only thing which we're missing from here is, number one, is a USB lead so that we can connect up to clean flight, and that just goes into that little socket down there. And the other thing which we're missing, obviously, is a power, an ESC, and a motor, but I'm not going to cover that in the setup. They're all pretty straightforward to do. So with that said, let's jump across to the desktop and look at the setup of clean flight for a flying wing over on the desktop, so you can replicate this if you want to for your flying wing as well.
So we've been and jumped across to the desktop. I'm going to go and plug in the Naze32 board. That's really straightforward. You just stuff a USB lead in it. I do have my transmitter on, and it is going to go and complain to us about a GPS fix. My office is like a nuclear bunker, and we will never get a GPS fix in here, so I will have to turn my transmitter off. But do listen to the commands which it tells us about, because those are super important. If you're flicking through the different flight modes, is that you can set your Taranis handset up to tell you which flight mode you're in, and also whether you have a GPS fix or not. And I'll show you how to do that in a separate video. So with that said, let's go and plug her in.
Telemetry recovered. GPS off.
Okay, so
GPS off.
there you go. So we can hear the Naze32 board's been connected.
GPS
And now
off.
my handset's telling me we don't have a GPS fix. So I'm going to turn my receiver off, okay, or my transmitter off. And that was the Naze32 board telling us that it lost connection. So I've been in clicked on connect in the top right hand corner. If I move the board around, okay, we can see that that's actually updating, okay, and also that we don't have a 3D fix at the moment. We can also see that we've got the full board, which we're using on here, and also sonar's not enabled at the moment because we don't have that enabled within the settings. We can see that it's in the motors are arming. Failsafe mode is not kicked in. This is one of my issues which I've got with the Naze32 board at the moment. And the FreeSky receiver, I cannot get failsafe to kick in, and I'll be looking at that in a later video. And also we can see that there's a serial link status. Now obviously I'm not going to cover all the details on how to calibrate and set up the Naze32 board. I am assuming that you do know how to do that. If you don't, there is a fantastic YouTube channel called Painless 360. I'll put the link to the video to Lee Schofield's channel underneath this video, and he's got tons and tons of videos. And when we get to the GPS setup, you definitely want to go and watch his video on how to do that. If we go to the ports on the left hand side, you'll notice that I have enabled soft serial, and the reason why I've been and done that is because we need the FreeSky telemetry being fed back. We also have GPS set up, and again do see Painless 360's video on how to set up the U-Blocks chip and GPS for your Naze board, and again the links to that are underneath the video. When it comes to configuration, this is about the most key section which you've got in here, is that what you need to do is set up and set the mixer section as being a flying wing. So that now tells us that on our Naze32 board that ports 1 and 2 are for the motors. Port number 3 is for the left aileron, and the port number 4 is for the right aileron. Also scrolling down, I have been set my min and max values for the throttle. Okay, so max throttle is set as 2000, although the Tyrannus does give us about 210, or sorry, about 2100. Then moving down, I do have the VBAT sensor on. That's something which I'll be hooking up later, and the Naze32 Revision 6 board can take direct voltage from your battery, so that makes things a little bit easier. When it comes to the current sensor, I'm not actually going to be using the inbuilt current sensor with the Naze32 board. Instead, I've got a separate current sensor for FreeSky, and I'll be feeding that back in. Hopefully, fingers crossed I can do that. I then have GPS enabled on the left hand side and set to U-Blocks. And a little tip for you, I really did find Auto Detect seem to work the best and give us the fastest fix. So rather than selecting NEMA or the other, sorry, instead of selecting European on one of these options on there, Auto Detect seemed to work really, really well. Then for the other features, we've got soft serial, we've got telemetry. Another note with FreeSky telemetry is that you need to invert it for the FreeSky receivers. Again, I'll put a video link to Painless 360 which will show you how to do that. You do need to drop an extra command in the console, the CLI option down here, which will invert the telemetry so it works with the FreeSky receivers. And also I've got the display enabled too. Failsafe is a topic in itself. I'm not that impressed at the moment because I can't get that to work. PID tuning, now I know that I'm going to have to come back and tweak these values, and the reason why I know that is because I have done a test flight with this and it's been all over the shop. And what I'm going to be doing is actually in the field connecting up a Bluetooth adapter to this. So I think it's a HC05 or HC06 Bluetooth adapter, and I'll be able to configure this Naze32 board via my mobile phone, so I can do quick ad hoc changes to go and chuck it in the air, see how it flies, and then I'll be able to tweak any of these PIDs as I need to. The next one on here, and it's vitally important that you get these correct. Now I'm going to go and turn my transmitter back on, so it will complain to us about not having a GPS fix. But when you set this up, it's vitally important that you do get these first 4 bars to work as expected. Now, if they don't work as expected, and for me on the Tyrannus, TAER1234 seems to work really, really well and seems to match up. So let's turn on the receiver.
Welcome to Tyrannus. Deactivated. Normal mode. GPS off.
Okay, so if I roll,
GPS
is the yaw, so that's the rudder. Okay, throttle is actually
GPS off. Active.
there we go. Throttle's enabled.
GPS off. Deactivated.
There's our
GPS off.
there's our left and our right on the right hand stick, and then our elevator
off.
up and down, and the servos are moving accordingly. Now I do have some other
GPS off.
let's turn that off. I do have some other switches set up, and those are really important when we get into the modes tab, which is next. And on here you'll see that I've been set up. So when I turn the motors on, which is my SF switch, okay, that will not only arm the board, that will also arm the actual motor itself, because again I've got some extra settings within the Taranis handset. You'll also see that I've got some other settings in here as well for angle and horizon mode. We've also got barometer mode as well. So angle and horizon, basically horizon's the new mode where the unlike in angle, again I might be incorrect on this one, whereas in angle it will only move like say 45 degrees either way, and it won't let you do a whole flip over, whereas in the horizon mode it will give you stabilization around the center of the stick, but if you want to rag it over and go fly inverted, it will let you. Barometer will help you with the height. Magnometer will help you with the direction. And then you'll see that I've got these set up with extra auxiliary inputs for GPS home and also GPS hold as well. So you can hold a position. Now, one of the biggest notes here is that when, unlike a quadcopter, which the Naze32 board is meant for, when it comes to a flying wing, you need pass-through enabled by default. And what that means with pass-through, all of your stick inputs get passed across to your flying wing. Whereas if you did that in a quadcopter, it'd go crazy and you just wouldn't be able to control it. Whereas with a flying wing or a normal RC plane, they're inherently an awful lot more stable. And again, as a pilot, you're much more used to flying with full control. And that's what pass-through is set up to do. It allows you to give full control. Now, let me just go and turn the receiver back on. So she is going to go and complain to us. But when we cycle through the switches, you'll see that they'll actually move on the screen. So let's go and turn her on.
Welcome to Taranis. Deactivated. Normal mode. GPS off. Active. GPS off. Rate mode active.
Okay, so it's telling me that we're in rate mode.
GPS off. Rate mode active. Horizon mode.
Okay, and we're going into
GPS
horizon mode.
Off. Loiter mode. Rate mode active.
We got loiter mode.
GPS off. Return to launch mode. Rate mode active.
Okay, that's a lot of chatting coming from the handset. But in short, what's happening there is that we're going from in between the different modes at the top, which we've set up just using the sliders and the auxiliary and the switches on the Taranis. And I've just set up voice confirmations on the Taranis handset. Now, we do have several other tabs in here. I won't be touching the adjustments. The servos tab is really important, and the reason why it's really important because servos 3 and 4, we may need to invert those, and we can do the direction change on the right hand side. So you'll see rate 100%, and then down here at the bottom rate minus 100%. That's how maybe your servos are in the wrong way round, for example, and you need them to move the other way because it's going down instead of up or left instead of right. That's where you can swap the direction and also change the rate of movement for the servos as well. Next tab is GPS. Now, obviously, like I said, my office is in like a nuclear bunker, so we're never going to get a GPS fix in here. If we did have a GPS fix, we'd see some green bars down here. The false would turn to green, and we'd also see our location on the map. Now, one thing I've noticed, even with a big U-Blocks chip, is that it does wander around. So when I'm out on the flying field with this setup, I am fully expecting it to really quite deviate quite badly, but it will kind of keep itself in line, if that makes sense, okay? The next tab we got is motors, and again, that's pretty straightforward if you've used the Naze32 board before. For quadcopters, Race transponder, it's completely irrelevant. And the sensors tab, if I move the board around, you'll be able just to confirm that your sensors are working. And the last tab I'm just going to point out is the CLI tab. And this is where you can add in any custom commands, maybe like the telemetry, for example, where you need to go and invert that. And also you can dump your command, all your settings out, and maybe you're doing an upgrade or something like that. So that's the basic overview to the Naze32 board. It is really straightforward to set up. I know there's a lot of tabs, and I know it does look really scary, but hopefully I've gone nice and slow through the different settings in here. And again, you can just pause and rewind them and copy them as you see fit. Okay, the next stage for us now is to go and get this connected up, maybe on something like a Texsumo, before we go and put it in the big FX61 flying wing. So we put it in something a little bit more robust to begin with, and just check over the flight modes and just check over the settings, and then get it into the FX61, and then really go and test this to its limits. So from myself, Matt, I sincerely hope that you found this video helpful. Like I said, no one else is doing or has done a video tutorial on how to set up the Naze32 board for a flying wing, and at least just gone through some of their basic settings to help you. If this is something which you'd like to do and you've got no prior Naze32 experience, then do check out the Painless 360 channel on YouTube. There are some fantastic tutorials on there. In fact, you will definitely need those tutorials when it comes to setting up the GPS, because you'll need to tweak the firmware on the U-Blocks board, and also when it comes to setting up telemetry for the FreeSky receivers, you'll need to invert the signal, and both videos for the GPS and the telemetry inversion are included underneath this video. So just go click on those links and go and watch those videos. It kind of sounds scary, but if you can manage copy and paste in both instances, it's really straightforward. So with that said, I really do hope this video tutorial has helped you, and in later videos we'll get this into a real plane, take it out onto the flying field, and see how she does. So with that said, cheerios.